All right, so if we come back to here, all right, so what did we say? We said draw a sketch. We said pick horizontal or vertical strips. Okay, now remember, horizontal are going to be dy. You're going to be in terms of y. Vertical is what we're used to. That's going to be dx. Okay, so with vertical strips, your equations are going to be y equals. With horizontal strips, your equations are going to need to be x equals. Now remember, we often, in place of y, we usually are often write f of x, right? Y and f of x are the same thing. Well, what do you suppose the function version of x equals is? G, or it could be g, but f of y. So sometimes you're given the equations as f of y. If I see f of y, I usually write x equals. If I see f of x, I usually write y equals. Okay, so if I'm giving them as function notation, I usually turn them into x and y because it just works better for these problems. Okay, as far as doing them. Now, one of the difficulties is when you go to your calculator. If you want to draw a sketch on your calculator, you have to do it as y equals, right? So if you're given the equations as x equals, that makes those harder to draw. Now, it turns out that you could just pretend they were y equals and graph them, and then you get the inverses of each one, right? Interchange x and y, you're getting the inverse. And it turns out if you graph the two inverses, the amount of area is the same. Okay? So you can make that work. But usually the ones we do are going to be easy enough that if I give them to you as x equals, you can solve them for y pretty easily and then put them in your calculator. Okay? So that's usually not an issue. All right, and then I guess I need a new page here. Number 3 would be top minus bottom is the key thing for vertical strips, okay, and right minus left is the key for horizontal strips. Top minus bottom, right minus left. And you set up your integral, and then you just, for the most part, most of the time, just type in your calculator. Now, I'll give you points for having the right integral set up, usually getting the right sketch, having the right integral set up, and then getting the final answer is the last part of it. Okay? Now, there is going to be some things asked on the homework where it's going to want you to draw some rectangles. For example, I may give you a curve that goes like this, you know, whatever, and you're supposed to find this area. And let's say, we'll just divide this up into, kind of neatly here, into 5. And let's say you were going to do this area from 0 to 5. And let's say this was f, this top curve is f, and this bottom one is g. So we would have f minus g. Okay, and so we're going to do this, but you're supposed to do 5 midpoint rectangles.
The pop bottles.
They're not doing pop. They are?
Yeah, they have to be. No.
Didn't they do those this term already?
No, they did
That
this
was
last semester.
that was before Christmas.
Yeah.
They're just starting.
It's a good thing that they started doing this after the drop date.
Yeah, that's right. Well, never make that. All right. So if we look at this, okay, here's at 1. Here's function values at 2, okay, 3, 4, and so forth. How would I draw a midpoint rectangle? Well, the first midpoint would be right there at 0.5, right? And so I'd go up to the curve right there and right there. And the difference is now, before, we had to draw the top of the rectangle, but the bottom was always where? On the x-axis. Well, now the bottom is going to be on the bottom curve. So what will happen is when we draw our midpoint rectangle, we draw the top, but we also have to draw the bottom. And then there would be your midpoint rectangle. Okay? And then we would have, and so let's say we were going to do left rectangle. So say you had to do 5 left, so let's scoot over here. So let's say we were at 3. Well, this is your left. Well, normally what we would do is we would draw over to here, and then down to the x-axis. Well, now what we have to do is we have to do the bottom the same thing. So we would do our left endpoint on the bottom curve and our left endpoint on the top curve, and then we would draw our rectangle from there. And there would be a left rectangle, okay? So we could still do left rectangle approximations on a graph like this, okay? And trapezoids would, well, no. Yeah, I don't, because then you'd have, oh yeah, you'd still have two parallel bases, that'd be fine. But finding the height would be, well, no, the height would be, because this would curve in, this would curve here, but the height's still your one, because that's still horizontal. So that wouldn't be that bad. I don't think you're going to have to. I think in the homework there's maybe a left problem. I think there's maybe a midpoint problem, but not too big a deal. We're not going to spend very much time on the rectangles. That was kind of chapter 5 and chapter 6. At the end of chapter 5 and into chapter 6, we did a lot with that. Might have a few problems here in this section, but for the most part, no. We're just going to be talking about that thin strip, infinite number of rectangles, doing our integral. That's the top minus bottom. That's what we'll worry about. Okay, last little bit here, and then we'll let you get to work. Let's do a few examples up here. Let's don't do that one. Let's do this one right here. So go ahead and graph those two functions on your calculator if you would. Negative x squared plus 2. This is how it's normally given. It would be graph the region bounded by these two curves. Now I usually, when I write them on my paper, I usually write y equals, okay, instead of f and g, which I think is fine. All right, now what do you notice? Are you getting a graph that looks like that? Now, the directions were find the area bounded by, the area of the region bounded by these two curves. What do you notice? They intersect in there in a couple places, 3 places to be exact. How does that affect what you've got to do here? We're going to have to split it. Now let's talk about vertical and horizontal strips. Here's your deciding factor. On a vertical strip, you need the top and the bottom to touch the same curves the whole time. On horizontal strips, you need the right edge and the left edge to touch the same curves the whole time. Vertical is the only way to go. Horizontal is going to, right here would be enough to tell me not to do horizontal right here. Because here the right edge touches that part and the left edge touches that part. Well, now I can do, it's like a sideways parabola. You know how we can divide it into top half and bottom half? And we have to do that sometimes. But dividing this into left half and right half would be a lot more complicated, okay? So right there I would say I don't want to do horizontal strips, for sure. Okay, and then look over here. Then you get the blue curve and the brown curve. Here you got brown, horizontal strips are going to be off. So we go with vertical. But now we got a problem here and here, right? Because here the top is the brown curve, the bottom's a blue, but what happens over here? It switches. And that's going to make a big difference, right? Now the other thing to consider is now once these cross, what about this area over here? That's not bounded. When we talk about the area of the region that's bounded by these two curves, that goes on forever and ever. That's not bounded, that goes to infinity. We're not going to deal with that. So that's not part of the region. So what we have is this region we got to find plus this region. They're both positive, right? So how do we do that? We split it. So now we got to find where they intersect. Now, it turns out they're pretty nice, but some problems as we go through the week and the weeks here, some of them are not going to land at nice places. So you go on your menu to analyze graph, you go to intersection, or else you just set them equal to each other and solve. You're going to have to find where they cross. It might not be unusual for you to have an integral that goes from 1.78398 to 2.60142, right? That may happen, but these cross at nice points. I think they cross at -1 over here, it crosses at 0 here, and it crosses at 3 here. I think is where those intersection points are. All right, so what will be our integral here? The first one will go from -1 to 0. -1 to 0, and which curve's on top? The cube. Now, here is a little trick for you. If the functions have been defined as g and f already, this is good on the AP test, it's good enough for me, then you can go ahead and just write that. Now, obviously, on your calculator, you're going to have to type them out, or you're going to have to define them, whichever you think's better. Probably just faster just to type them out, because to define them, you have to type them out also. Okay? But if you've already graphed them, they are stored in like f1 of x and f2 of x, right? So you could use that. You could use those definitions if you've already graphed them. They are stored there. Is it f1? Is that how they're stored? So you could just do f1 minus f2 or f2 minus f1, make sure you get the right one. So you could type that in that way. All right, and then we're going to add that to the integral from what? 0 to 3, except this time it would be f minus g. Right? Because we got to do top minus bottom, because that'll keep them positive, which is what we want, because the top y value is bigger than the bottom y value, so when we subtract them, we get a positive length times our positive width, we get our positive area. And so what is it coming out to be? According to this, whoops, I didn't realize this. It wouldn't let, okay, no big deal. So I need to go from -1 to 0. I need to do these separately. Okay, we can do that. So the first area came out to be that. I don't know what number that is. And then the second one ends up being from 0 to 3. Oops. Okay, so we get a grand total of, what do you guys get for your final answer? 11.833, that's what mine would be, or as a fraction, something else. How much? 71 over 6. 71 over 6. Okay? All right. So that would be that scenario. Here would be another situation if you had like sine and cosine, that kind of thing. All right? We would get that, we would get into that same business. Okay, let me look at this one for you now. Okay, so right here, notice how this one is written. F of y equals y to the fourth. Well, I would write that on my paper as x equals y to the fourth. And for this one, I would write that as x equals 2 minus y squared. Okay? Now, if I needed to graph this, which I think I would need to probably, then you need to solve them for y. So y on this one would be what? X to the 1/4, the fourth root, And this one, we would have a little work to do. If I'd add the y squared over to here, subtract the x, then I've got to do a square root. Don't forget a plus or minus. So on your calculator, you'll probably have to do 3 graphs so you get the top and bottom of this parabola here. Plus or minus the square root of 2 minus x. So what you're going to need to do is graph those two right there. But it's a big hint to you when they give you the problem as x equals that you're going to do what kind of strips? Horizontal strips are probably going to be pretty nice to work with. All right? But first we would need to solve for y here. So let's go ahead and let's graph those. It's actually going to be 3 graphs because this is going to be the top and bottom half of a parabola. All right? And then that's going to be that one. So let's go ahead and graph those. And actually, to be honest, guys, I don't care if you take time to get those in there right now. I think we should know how to graph, but I want to make sure you can do the graphs there. Okay, so what do we get? This would be, the brown one would be the top and the bottom half of that parabola. This would be the graph of x to the 1/4 power. Oh, you know what? We should have done plus or minus on that too. Because we did the 4th root of both sides. That's the same as doing the square root. As far as anytime you do an even power root, it's a plus or minus. Okay? So the blue graph is that x to the 1/4 power, but it's plus or minus. And the square root one, the plus or minus is there. Okay? If we wouldn't have done those, we wouldn't have had any boundary. Now, do you see the problem with vertical strips right off the bat then? I mean, vertical strips are going to hit the blue graph here, but then they're going to hit the brown graph on the top and bottom there. And now we have those two halves, so it isn't that big a deal. We have that plus minus. So we have the top half of the blue graph, and we have the bottom half of the blue graph. It's negative x to the 1/4. So we could still do top minus bottom and top minus bottom, right? We could do that. But horizontal strips are going to work really nice. The right side of the strip will hit the brown. The left side will hit the blue. So right minus left will simply be the brown x, which is 2 minus y squared. So let's type this in just on your calculator screen. So the right x is 2 minus y squared. The left x is y to the 4th. So it's 2 minus y squared minus y to the 4th, and it's going to go from where to where? The strips will fill the space. I think this intersection down here is -1, but that's something you'll be able to find. And this intersection's up here at 1. So the strips will fill the space from -1 up to 1. And I'll go ahead and sweep that through there. So the red horizontal strip is filling the space from -1 to 1. And you should, on your calculator, get an answer of 2.933. I don't know what that is. It's a fraction. How much? 24 over 15. 44. 44 over 15. Okay, 44 over 15. Again, I would just leave it in terms of that. All right, so that's one where horizontal strips work quite a bit nicer. The only difficulty was we had to solve for x just so we could get a graph and get a picture of it. But it was already solved for x. Okay, last thing, I'm not going to make you work through this. That way you get some time to work here. I want you to look at this one. Here's one where horizontal and vertical would work equally nice. Right? Vertical strips, brown on top, blue on the bottom. So here's y equals a cubic is the blue, y equals a line is the brown. And so we could just, and it crosses at 0 and at 2. So the strips would fill the space. If we look at that, the strips would fill the space from 0 as we go across to 2. All right? So it would be the brown minus the blue from 0 to 2. Okay, now let's look at that same situation, except solve them for x. Horizontal strips would work very nice here. The right would always be on the blue, the left would always be on the brown. So it would be blue minus brown. We'd have to solve for x. They were pretty easy to solve for x. Okay, we had y equals 2x, divide by 2, you get x equals 1/2 y. Okay? We had y cubed over 2. We had 1/2 y cubed. You multiply by 2, that'd be 2x, or excuse me, 2y, and then do the cube root. So it'd be 2y and then the cube root. So now, the strips would fill the space from 0 to where? That's a 4 up there. From 0 to 4. So our first integral went from 0 to 2 because the strips filled the space this way from 0 to 2. Horizontal strips are going to fill the space from 0 to 4. And we get the same answer. We get 2 either way. Okay? So sometimes, and you're going to have some of those. On the homework, sometimes they're going to tell you, on some of the homework problems today, they're going to say, use top minus bottom. Now, the way they'll say it is they'll say, do f of x minus g of x, dx. And then they'll say, do f of y minus g of y dy. In other words, they're saying use horizontal strips. So you'll have to do it with vertical strips or you have to do it with horizontal. There'll be others where you just get to choose. Most of them will be pretty obvious. One is better than the other. Okay? So that's the whole idea on the homework today. All right. So the last assignment sheet of the year.
Please stop.
Okay. April Fools, no.
April.
All right. All right, the first. Yes, you can put this on your graduation table next to your library project. Last assignment.
Didn't you think that my rare project was so pretty?
Now, first line. So again, some of the early ones have multiple parts where they have you do maybe some. You have to draw some sketches, maybe draw some rectangles like those midpoints, those last we talked about. But then also just set up the integral and do the integral as well. And then there's other ones at the end where, like I told you, I think on 17 and 23 you do them with vertical strips, and then 29 and 35 are the same exact problem except you do them with horizontal strips. So.
Oh my gosh, it's not all Anybody know how many days left? Well, yesterday was 30. Today? Oh, now it's only